mentioned, you have 3 hours to take the exam, no more than 3. You can leave after 2. All right, if you are totally satisfied that you've done your best work possible and everything is correct as it's going to be, you can leave after 2, but you have 3 hours total to take it. So let's get into similar triangles. Here we go. First thing I want to review is not question number 1. First thing I want to review with you guys is 1, 2, 3.5 ways to prove triangles similar. All right, we had 3.5 ways when I covered similar triangles. Main way I'm hoping everybody knows already, and that is angle. Specific, especially when we're doing a proof. If you're doing a proof and somewhere along the lines, if it's in the middle or at the end, you need to prove 2 triangles similar, it's got to be angle. But you might have algebra problems to do as well with similar triangles. So there are, I want to go over the other 2.5 methods. We did have angle. We also have side with our little tilde there. That means all 3 pairs of sides are in the same ratio. That's what SS said. They're not congruent. They're all in the same ratio. We also had nothing, huh? It is side angle. And there you go. The angle in between is congruent, but the other 2 sides around it are in the same ratio. And then we had this half one, which is, you can use it. Always remember it. You never know. It may come up if the triangles are congruent. That means they are similar. Not the other way around. Okay, it's only if they're congruent, they're similar, not the other way. All right, so keep in mind those 3.5 methods of proving triangles similar. So let's take a look at number 1. Angle H and angle RDO. Let's make sure we mark those with our arc marks, are congruent. And then I provide you guys with some side lengths. RD being 4. We got RO being 6. OH is 4. What's the length of CD? We'll stop right now before we even start answering this question. How do you know these deal with similar triangles? They're in this. Yeah, but you're not going to know that in 3 weeks from tomorrow when you're taking the test. How do I know this is a similar triangle question? Got a pair of angles, and which angle do they both share? Angle R. So everyone see angle now. These 2 triangles are indeed similar to each other because of angle. All right, now if they're similar, that tells me the corresponding sides are in the same ratio. We called that CSSTP when we did proofs. All right, so I know the triangles are similar by angle. Corresponding sides are in the same ratio. Help me build the proportion now. When you build the proportion, I can't get fired up enough about this. When you build the proportion, full sides only in the proportion. Do not put a partial side in of a triangle. Full sides only. So I'm going to start with triangle DOR, the small triangle. I need somebody to give me a side that you already know of that triangle so I can start my proportion. Give me a side. Small triangle, DRO. Give me a side we already know here. Whoo, Thomas. OR. All right, so Thomas is going to start with OR. Fine with me. That's 6.
Does that count?
No. Good try. Could have been a bunch of things. Next one. What does OR correspond to? What does OR correspond with up here? This is going to be the tough part. You need to make sure you take those 2 congruent angles, put them right on top of each other, and then say, all right, what would OR land on in triangle CHR? This is a visual thing right now. And if you don't like the because I'm not a visual person, if you don't like that, separate them. Draw them separate so you can see what matches up with what. I need to know, because that's the side length I'm going to put underneath. What does OR correspond with in triangle CHR? And before you tell me that, you better make sure both of those angles are on top of each other and angle R is right on top of itself. So what does OR correspond with? Don't tell me the length, just tell me the side, please. What does OR correspond with? Side what? I get it. It's tough. I agree. It's the first one of the day, too. Why not? OR corresponds with, what do you think over there, Ian?
The CD.
C.
D.
That's not a full side though.
Oh, CR.
CR, yeah, right? I want full side, so it corresponds with CR? Yes, it does. Tell me the length of CR now. What is the length of CR based on that diagram? Because that's what I want to put underneath 6. Doyle, what's the length of CR? Thank you for not multiplying them. X plus 4. And I'm going to tell you tricks here along the way that I never told you in the year because you're honor students and you shouldn't be using tricks. But here's what I use sometimes if I can't visually see what sides match up. Like if I didn't understand why OR and CR match up, the corresponding sides are always across from the congruent angles. Like, look, we had OR was across from this congruent angle. So the side that it corresponds with should be across from its congruent angle. Make sense? The corresponding side should be across from the congruent angles. All right, good job. We're almost done now. Give me another side that we know in the small triangle. Another side we know in the small triangle. Ian, back to you. I've already used OR, so I'll probably use DR, 4. Yep. All right, let's do the same thing. What's DR going to correspond with? What is DR going to correspond with in the large triangle CHR? DR and Matt. What side is that?
HR.
HR, yep. And how long is it, Matt?
10.
Sure. Right. Oh.
Okay.
I will give you not full sets, but 2 partial sets of scratch and sniff stickers here. Okay, one is sea breeze scent and the other is strawberry scent. Now these have been in there for 2 to 3 years. I probably bought them, so decent. Okay,
What
decent.
exactly did you buy them for?
What's that?
What did you buy them
I used to put them on tests and quizzes for anybody that got like 95 or above, but I just stopped doing that. I don't know why. 14, Gianna, congratulations. Don't share them around too much. All right. Scratch and snips. Not full sets either. Look at that. I'm just giving away everything here.
Where do you keep this room? Like, is this been your room?
Yeah. Not all time, but probably whenever they built, because this is considered a new wing that they built when they built Eagle. They took care of some of the high school too. So this is probably 10 years, 11 years I've been in this room.
Yeah. Do you just keep all your stuff up?
Oh yeah. I'm not creative at all. Like the last time, I don't know how many people know Mrs. Linehan. She's the other honors geometry teacher. I had her as a student teacher. And when she student taught for me, she made that Who Knows the Basics board over there. And I just haven't, like, should I put a new one up? Probably yes, but I'm not that creative. So I'm not going to be doing that at all. Like what you see is probably the original setup of stuff. We never had the TVs. I used to be on the whiteboards. I told you guys about that. And then there used to be a huge like monitor up there attached to the wall. And then there used to be like a projection screen. See that hole right above where Will is sitting right there? That hole there used to be a projector that used to project onto that big screen that used to be over there. And that's how I did notes. That's when the flip charts came into play, and then they gave us the TV. So, and this is the first year I think I've had the TV up here. I had the TV back there before. So like all that stuff that you see back there used to be up front here, and I had the TV back there. This is the first year I had it up here. I like it a lot better. All right, good stories. Anyway, moving on. And of course, it'll probably stop here. Whew, there we go. Thomas, what do I have here for X? 11. And notice everyone, we called X 11. We called CD is X. We don't have to add 4 to it or anything. It's just 11. All right. I'm going to do the same thing I did yesterday. I'm going to skip over a couple so you can do them in your group, which I'm going to skip over 2 and 3, and we're going to go right to number 4 now. I'm telling you the two triangles are similar, but here's the part you got to be aware of. I want them to be similar by side angle side. So what combination of side lengths and angles would make them similar by side angle side? I want side angle side. I'm going to get rid of two of these examples, two of these answers quick. 3 and 4 are out. And I don't even care what I made the side lengths. Anybody, I'm going to ask somebody right now, why am I getting rid of 3 and 4? Automatically. Done. I don't even care what the side lengths are. Why am I getting rid of 3 and 4 automatically here if I want it done by side angle side? Oh boy. Aiden, why am I getting rid of those two?
Because the angles on between.
Darn right, yeah. I'm C and F. Look, there's C. That's not side angle side. It's got to be A and D. Got to be. So now I look at A and D, choices 1 and 2, and I say, all right, is it 9 and 12 or 8 and 10 going to be in the same ratio as my 6 and 8? So I'll let you guys test that out. What combination, 9 and 12 or 8 and 10, will have corresponding sides in the same ratio? And which pair up here lands in the same ratio up here? Josh?
DE and DF. Or wait.
They're both DE and
What are you
DF.
asking? Like,
Is it the 9 and 12 or 8 and 10?
9 and 12.
9 and 12. Good. And just quickly, if you guys a little confused, 6 matches up with 9, 8 matches up with 12. Check those ratios on your calculator, or you can always cross multiply. 72 equals 72. Yep, that's the same ratio. All right, good work. Questions there? Okay, I think I'm going to do one more from this similar triangles, and that's number 6. Asking you guys, based on this information, are these two triangles similar or not? So RS is 6, ST 14, XY 9, YZ 21. And what do I have? Angle S and Y are congruent. I don't know if the answer is yes or no, they're similar, but I know the only way I can check is side angle side. That's my only option based on what I was given. Right? That's my only option is the side angle side method. So we have the angle in between. Now it's up to you guys. Are those sides in the same ratio or not? And if you say yes, I want to know, how'd you check if they're in the same ratio? All right, what'd you find out? Are those corresponding sides in the same ratio, Doyle?
Yeah.
Yeah, they are. What'd you check, Doyle?
I divided, you divide 6 by 2 and then add that to 6, it's 9, and then if you do the same. Well, it's, okay.
This guy.
6 over 9 and then 14 over 21.
Thank you. Yes, those are in the same ratio. Yes. Doyle's doing some high-level calculus over there to see if they're similar or not. So yes, they are, because it does say, are they similar by side angle side? Make sure I get my little tilt on there. Good. Any other questions, comments there? I'll let you guys do the others in a second. Yes, Ian?
Do we lose a point if we don't do the tilde and like the curve?
Probably not. I'll be honest, probably not. No. I will, but while they're on the topic of proofs, that's going to be a whole other day coming up. But I can tell you because this did happen, I don't know how many years ago, but it did happen. You start, yeah. And the givens were written somewhere up here. And I had a student or two do this. You're going to lose a point if you don't write the givens in. You just pull the arrow there. Okay, so just a heads up, that did happen because it's technically an incomplete proof. So that's what happened, and they lost a point. So just a heads up there, write everything in. Don't be lazy. All right, good story. Let's go to the second most commonly tested topic. What I think on the Regents is dilations. Okay, not just blowing something up or shrinking it. It's a dilation of a line. You're going to see a question or two, maybe three, dilating a line, and that's exactly what we're doing here. We're taking line L. All right, we're taking line L, which they give us is 3x minus y equals 4. And they're going to dilate it by a scale factor of 2 centered at the origin. And what is line, what are we calling this one, M going to be? That's what I want. Okay, so I'm taking line L, dilating it by a scale factor of 2. What's line M? All right, well, let's stop right here. We have done 2 days of this already. We've talked about it during day 1 and day 2. If you're going to write the equation of a line, I don't care if it's a dilation question, parallel, perpendicular, you need what 2 things? You're going to write the equation of the line at the end. What 2 things do I need? Come on, Doyle.
The slope.
Yep.
Y-intercept.
You got it. So that's the 2 things I need from you guys before I write the answer here. Now let's talk about it's being dilated. Remember, lines don't get bigger or smaller. Line segments do, but not lines. They don't get bigger or smaller. But what happens is dilated lines remain parallel to your original lines. Remember that. When you dilate a line, it remains parallel. It doesn't get bigger or smaller, but it does remain parallel. Remain parallel to the original lines. And I bring that up and let you guys know about that fact because if they remain parallel, what's going to stay the same between them then? Slopes. Find the slope of line L. Find the slope of line L for me. You guys know how to find that, find slope. You either put it into y equals form and let me know, or you use your calculator because I showed you how your calculator can tell you what the slope is. Little details from it. What's the slope of line L? Slope of line L. Shoo, Thomas. Negative. Slope. Where's the slope located? It's in front of the x after you solve for y, right?
3.
So it should be 3. There's my slope, which means come on over. Slope of my dilated line will be 3. They remain parallel. All right, now how the hell do I get the new y-intercept? Okay, well, let me go back here. Let me first ask you guys, what was your old y-intercept of the line we're dilating? Line L, what was that y-intercept? Look at your equation, or the calculator tells you 2. Kissinger, what do you have there? What's your y-intercept? -4, good. And I asked because the second part of this problem, which is we're dilating around a specific point, the origin. Something real nice happens when you dilate around the origin. And that is only when you dilate around the origin, you can multiply by your scale factor. Only, though, if you're dilating around the origin. So you can take your y-intercept, which is what? 0, -4, or -4, and multiply the coordinates by 2 now to find the new y-intercept. All right, but again, that is only when I dilate around the origin. Well, what happens if I don't? I'll talk about that at the end. So what is going to be the y-intercept of my dilated line now that I can multiply by 2? Whew, Haley? -8. Okay, multiply 0, -4 by 2, and that's what I end up. So what's the answer to this question here? What's the equation of line M? Put the 2 together for me. Josh, put the 2 together for me. What's line M?
Y equals 3x minus 8.
Good job. All right, good work. Dilated lines remain parallel. If you're through the origin, you can multiply by the scale factor. Questions, comments, concerns? All right, a couple more here. That's not number 12 on yours. That's number 15 we're about to do. Number 15. Dilate by a scale factor of 3. What's true about the new triangle? I'm going to get rid of 2 of these right away. When you dilate, what happens to angles? Nothing. They stay the same because the triangles are always similar when you dilate. And when you dilate 2 figures, they're always similar. So the angles are congruent. Now, I've had all my classes had trouble with picking between 1 and 2. Remember, the image A prime, B prime, C prime is going to be 3 times bigger than ABC. So which one is showing me that the side lengths of the image are 3 times the size of the original? Okay, which choice is showing me that? People have had issues, and I understand why. But I want to know the sides of the image is 3 times the original. Which one is showing me that? Zoe! It is choice 2. Yeah, lucky us, huh? It is choice 2. Everyone good? I don't really mind, other than it's just extending class longer. You don't have time to. Do I do that one, or do I save that for win random stuff? Why not, right? One of my favorite classes. Why not? Why not give away this old radio / CD player that's been in here forever? I don't even know if it works anymore. We'll test it, huh? You guys even know what CDs are? Huh? There you go. Pop one right in there. Let's see, does this bad boy still work? Oh! Blinking, it works. It works. Oh, the radio works too.
When was the last time you used it?
Can you tell? I have no idea. Yeah, there we go. Yeah, it works. Perfect. Look at all this stuff that's on here. Set the alarm. Some lucky person here. All right, here we go. I should have saved this for WinRAM stuff, but hey, it is what it is. I know everyone's going to be real excited about this. Are we ready? Real excited. 5. Haley, there we go. Congratulations. Look at that thing. How long that's been in there. That thing used to be white, by the way. All right, white. I'm pretty sure. All right, but it's been in the filing cabinet for years, taking in some heat and sun. So, congratulations there, Haley. Don't enjoy it too much. All right, let's go to the last problem I have on there, number 17. Again, dilating by a scale factor of 3. Which statement is true? Which statement is true? Can we get rid of number 4? Is that all right with everyone? I get rid of number 4. We just talked about that because the corresponding angles stay the same. All right, they're not going to increase by 3 times the amount. Look at number 3. The slope. Does the slope go 3 times? No, what did we just figure out? The slopes are the same because the lines stay parallel. So that's out. So now it's a discussion between what increases by 9 times the original, the area or the perimeter increases by 9 times. I guess we could make up a fake problem and see, right? Find the perimeter and area. But I taught you guys a little something in Unit 11, which said if you know the side ratios of 2 similar figures, how did that relate to the perimeter? And if I knew the side ratios, how did it relate to the areas? Because that'll be my answer to this question. Anybody remember how these related? Man! They're always equal, yeah. So if I'm telling you this triangle had a scale factor of 3, guess what about the perimeters? It'll be 3 times the original because they're always equal to each other. Versus this one, these were not equal. These were not equal. What did we do to adjust them? Matt, come on, Matt. Side one squared. Yeah, you had to square them, right? So if I was in a ratio of 3 to 1, like this scale factor is, what's my area going to be? 9 times. Okay, makes sense? 3 times for the perimeter because they're equal, but 9 times for the area. Good. Oh, should I do it? Hey, what's the answer to this problem? Oh, sorry. Olivia, what's the answer to this one? Good job. Choice 1. I do need you guys to, you got some white space right below number 17. I do need you to make a little note. That's a very, very important one. In this first problem we did, we dilated around the origin, so we were allowed to multiply. Where else could you have a center that you're dilated around? You guys will probably remember this when I start writing it. It may not be the origin, but what happens if the center is already on the line you're dilating? Remember that one? The center's already on the line you're dilating. So let me get to that. I want to word it correctly. So if the center of dilation is on the line, on the original line. Anybody remember what happens?
It stays the same.
Nothing. Stays the same. Good, Josh. Nice. If the center of dilation is on the line, the image is the same line. So keep that in mind. The Regents loves the poke, make it seem like a complicated problem with a crazy like a scale factor of 1/9, but the center is actually on the line. It stays the same line. Okay, good. Okay.